Greetings, physics fans. This is Mr. Resentis again, and I'm on Chapter 8 talking about fluids. And you can find this on page 274 of your text. I'm on page 274 of the text, Chapter 8, talking about Archimedes' principle. Now, Archimedes' principle, the buoyant force is equal to the weight of the displaced water. So this would just be what we would consider the weight in the air, force times the force of gravity, the mass in kilograms times the acceleration. Then we submerge it in water, and then there's some displacement, and so that's what this little spout is. There's displacement of water. So the water displaced, the weight of the water displaced is equal to the buoyant force. So that's why there's 7 pounds, 3 pounds difference between the air and the apparent weight, the submerged weight, and that 3 pounds is also equal to the amount of the weight of the water displaced. All right, that's Archimedes' principle. And there's some other vocabulary that we should know regarding this, and that is apparent weight. Apparent weight is the immerged weight. Once it's underwater, the immersion weight is the apparent weight. Immersion weight in a fluid, and we're going to be talking about water for the most part. This is you could apply this to any fluid. Now, we could say that the weight in air is just force of gravity. We've been talking about that throughout our discussion on mechanics. Now, the weight in water we could call the force in water. I'm just giving it F sub W. The force of gravity minus the force in the water, the apparent weight, equals the force buoyant, the buoyant force. So all I've done was I've just subtracted these two and said that the difference is the buoyant force. That's all I said. All right, so the mass density equals mass over volume. We know this by now. And don't forget, you're going to have to find the density, because I'm going to show you the relationship between density and buoyant force in a minute. So that's why you have to know what mass density is. You have to be able to find it. And so don't forget from your studies that you can set up a simple triangle. And if you want density, it's mass divided by volume. If you want volume, it's mass divided by density. And if you want mass, it's density times volume. All right? So you'll see this in a Greek letter rho. You'll see this in the Greek letter rho. And so if you see Greek letter rho sub F, that's just the density. That just means density of the fluid. Alright, so rho of F is just density of the fluid. And for the most part, we're going to be talking about water. So, and the density of water equal, I should say, of density of fluid, water equals 1 times 10 to the third kilogram per meter cubed. Alright, so water is 1 times 10 to the third kilogram per meter cubed. That's the density of water. And you'll be using that. You might also see rho sub O, and that would be the density of an object that's floating around or submerged. All right. So buoyant force is you should be able to define buoyant force. It's opposite of gravity. It's an upward force. And it's the force applied to an object immersed in a fluid. So it's the force applied to an object immersed in a fluid. Alright, now the buoyant force is dependent on how deep it is. So there's a greater buoyant force on the bottom of an immersed object than there is on the top. So these vectors on the bottom would be larger than these vectors on the side. So that's why the force is greater on the bottom. But it's equal. But there's an equal force all the way around. Anyway, the force buoyant, and remember, this is not to take the place of your reading. This is just to summarize and clarify. Force buoyant equals the density of the fluid times the volume times gravity. Right? So the rho times volume times gravity. So here we could see the role that density plays in buoyant force, because there's a direct relationship. As density goes up, the buoyant force goes up. As the volume goes up, the buoyant force goes up. And force of gravity is 9.81, and on our planet it doesn't change much, does it? So there's two ways I've already showed you to how to solve for buoyant force. So buoyant force is also, as you can see, we could also solve for buoyant force is the mass of the fluid times gravity. All right. So that's let's see where I've lost my train of thought. Oh, buoyant force equals the weight of a floating object, right? So that's why I could say that the buoyant force is equal to the mass times gravity. Force buoyant equals mass times gravity. All right. So that's the third way you could find buoyant force. Anyway, here's a practice problem. Practice problem on page 279 here in chapter 8. A piece of metal, 50 newtons and 36 newtons apparent weight. When apparent weight is in water, I assume. And 41 newton apparent weight in an unknown liquid. What is the density of the metal? That's our first question. And then, what is the density of the unknown liquid? Well, in order to answer this question, we have to recognize there's a relationship between the force of gravity, the buoyant force of the object, and then the density of the object divided by the density of the fluid. That's important to recognize that relationship. Now, in order to get the buoyant force, all we have is the apparent weight and the weight in air. So we're going to have to subtract the two. So force buoyant equals the force, I guess, of gravity in air, I guess we can call it, minus the force of gravity in water. So I just said force of gravity in A and force of gravity in W. So that's just 14 newtons, because it's 50 minus 36. I just subtracted those two and got the buoyant force. Now that I have the buoyant force, and we know the force of gravity is 50, so 50 newtons over 14 newtons equals the density of the object divided by the density of the fluid, which is 1 times 10 to the third. And so if we solve for P of O, it's just, and remember we're talking about the metal. We're doing the metal first. It would just be 1 times 10 to the third times 50 divided by 14 equals 3.57 times 10 to the third kilograms per meter cubed. All right. So those are the density, and those are the units for density. All right. So that's for the metal. The unknown liquid. We're basically going to do the exact same thing. So the buoyant force, the force buoyant equals force of gravity in the air minus the force of gravity in water, and when we do that, we just 50 newtons minus 41 newtons equals 9 newtons. So that's our buoyant force. So 50 newtons divided by 9 newtons. Plugging it back into this equation, because we're solving for the density of this unknown liquid now that we know the density of the object. And so I'm going to put the density of the object here times 10 to the third divided by rho sub F, which is the density of the fluid. Alright? So now if we want to solve for rho sub F, it's just 3.57 times 10 to the third divided by 50 divided by 9, and that gives us 6.42 times 10 to the second kilograms per meter cubed. Okay, and so don't forget, this is the fluid, and that's the metal. Right? So we solved for the metal, and we solve for the fluid. Right? One more. Let's do one more. This is I think number 3 in that same practice A. There's only 3 or 4 of them. A ferry, 4 meters by 6 meter, loads a truck. The ferry sinks 4 centimeters. What is the weight of the truck? Well, let's have a look. Force buoyant equals the density times the volume times gravity, right? Well, the volume equals 4 times 6, and this is just a little red flag. We know we have to have them all in the same units, so it's just 4 times 6 times 0.04. Turn that into meters, and that gives us a volume of 0.96 meters cubed. And so we just multiply the density of the water times the volume, which is 0.96, times the force of gravity, which is 9.81, and that gives us 9.4 times 10 to the third newtons is the weight of the truck. What?